When choosing next job to run, look at all processes in the ready state and dispatch the one with the smallest service time.
We must assume that we know the service times.
We consider it as a non-preemptive algorithm.
A new job will not be given a chance at the CPU until the current job finishes, even if new job is shorter.
All of the 5 jobs, P1, P2, P3, P4 and P5 arrive at the same time. The operating system will compare them and find out the shortest service time to execute. Therefore, job P2 will execute first, job P5 next, job P1 then continue, and later follow by job P4 and P3. Job P1 will arrive at 0 second and starts first. The service time of P1 is 140 second, so P2 which arrives at 40 second and P3 which arrives at 50 second will wait to execute. P1 completes at 140 seconds and the turnaround time is subtracted from completion time with arrival time. Therefore, the turnaround time of P1 is 140 seconds. After completion of job P1, the operating system compares the service time of job P2 and job P3. The P2 which has shorter service time is executed first. P2 then complete at 215 seconds. The turnaround time of P2 is 175 seconds. After that, job P3 executes. The service time of P3 is 320 seconds. In the executing process of P3, job P4 and P5 arrives. However, job P3 will continue execute until it finishes at 535 seconds. The turnaround time of P3 is 485 seconds. After that, the operating system compares the service time of job P4 and job P5 to decide which job will be executed next. P5 will be selected because service time is shorter. P5 completes at 660 seconds and turnaround time is 345 seconds. Lastly, P4 will execute and the completion time is at 940 seconds, whereas the turnaround time is 640 seconds. The average turnaround time for the whole system is 357 seconds. SRT is a preemptive variant of shortest job next, SJN.
It allows a job to be interrupted if a new job arrives which is shorter than the remaining processing time of the current job.
Later, when choosing job to dispatch, base on each job's remaining processing time, rather than the original times. Job P1 will arrive at 0 second and start first. While executing P1, job P2 arrives at 40 seconds. Job P1 stops and the remaining time becomes 100 seconds. After that, the operating system compares the remaining time of P1 and P2. P2 has shorter remaining time, so it executes first. P2 continues to execute until P3 reaches at 50 seconds. The system compares P2 and P3. P2 has shorter remaining time. Therefore, P2 continues to execute. P2 then completes at 115 seconds and the turnaround time is the subtraction from the completion time with the arrival time. After that, the operating system compares the remaining time between P1 and P3. P1 has shorter remaining time, so it executes first. The completion time is at 215 seconds and the turnaround time is 215 seconds. After that, P3 will execute until job P4 arrives at 300 seconds. The operating system then compares the remaining time of P3 and P4. P3 has shorter remaining time. Therefore, P3 continues to execute until P5 arrives at 315 seconds. The operating system compares the remaining time between P3 and P5. P5 has lower remaining time, therefore, P5 executes first. The completion time of P5 is at 440 seconds. The turnaround time is 125 seconds. The operating system then compares the remaining time of P3 and P4. P3 has shorter remaining time, therefore, it executes first. The completion time of P3 is at 660 seconds and the turnaround time is 610 seconds. Lastly, P4 will execute. The completion time is at 940 seconds and the turnaround time is 640 seconds. The average turnaround time for the whole system is 333 seconds,